Hello, today what we'll do is learn how to write equations of a line given a point and a slope, or given 2 points. What we're doing is building on the previous lesson about how to write equations, which is thinking backwards, given information about a line, and then giving the equation of it. So we're continuing with that, but getting into more complicated material, so more complicated pieces of information. So what we're going to use is something called the point-slope form to write equations, and that's the title of the notes. We're going to use point-slope form to write equations. And we're going to get some more information, we're going to think some more, and put it together to write the equation of lines. So just as always, we're going to start with the pieces of prior knowledge that we need. And we start with the ability to label ordered pairs. We're going to ignore that phone call, this is on the video. So if I had 2 ordered pairs, 3, -6, and 0, 1, I'm going to need to remember how to label those. And that was from the video on how to find slope from 2 ordered pairs. So remembering that the first ordered pair is x1, y1, second ordered pair is x2, y2. So we're getting into that previous knowledge. We also need to remember about the distributive property, how multiplication is distributed through grouping symbols. So if I had an example of 2/3 times x minus 6, I can distribute this 2/3 through the parentheses. I'm intentionally using a fraction because we will see lots of fractions in this lesson. So distributing through, that means I am multiplying 2/3 times x and 2/3 times this -6. So 2/3 times x and 2/3 times -6. So I have to remember how that works. 2/3 times x is 2/3 x. 2/3 times -6 is 2 times -6, which is -12 over 3. So I'm remembering how to multiply fractions times integers, and then I'm going to simplify what I have left. 2/3 x remains the same. -12 over 3 becomes 12 divided by 3, which is 4. So I have 2/3 x minus 4. And that's a piece of prior knowledge we have to recall. We also need to remember how to solve equations for a specific variable. Here's an example if we were to solve the following equation for y. If I had this equation, I need to solve it for y. That means I need to get this y by itself. All I have to do is add 7 on both sides. I have to undo that -7. So I'm remembering how to solve equations for specific variables. I also need to remember that when I'm adding 7 to both sides of the equal sign, where can I add that 7? I can't add 7 to 2/3 x. This has an x, the 7 does not. I can't add the 7 to this. The only thing I can add the 7 to is the -4. So I'm also remembering that when I'm adding 7 on both sides, what exactly can I add? So if I'm solving for y, I'm adding 7 on both sides. I'm left with y equals, which is what I want, 2/3 x, and then -4 plus 7 is +3. So there's that piece of prior knowledge I need. I also need to remember about slope-intercept form. Y equals mx plus b, where m is the slope and b is the y-intercept. So I'm building off of that prior knowledge. And finally, the prior knowledge that I need to remember is the slope formula. Given 2 ordered pairs, how can I find the slope? Remember, I'm looking for the change in y over the change in x. Subtracting the y coordinates over subtracting the x coordinates. So there's that piece of prior knowledge as well. And if you forgot how that works, go back to my other video, how to find slope from 2 ordered pairs. And that will help you. So now we're ready for new knowledge. We've anticipated what we need to remember. Here's what's new. So what's new is something called the point-slope form to write equations. The point-slope form. And you use this form in order to write equations of lines given certain information. And remember from the last lesson, we need two things to write an equation. We need a slope and a point. I think we're going to use point-slope form. So to write an equation, we need a slope and a point. Once we have that information, we can use point-slope form. This crazy looking formula, which basically states y minus y1 is equal to the slope times x minus x1. And this looks pretty confusing, but with practice, it becomes a lot easier. So this y for the formula stays y. The minus sign stays in the formula. y1 is the y-coordinate of the point that we have. Okay, so remember, we need a slope and a point. The y1 comes from that point that we have. It's the y-coordinate from the point. The equal sign stays equal. The m is the slope that we have. Remember, we need a slope, so the m is the slope. This x stays x. This minus sign stays there. And x1 is the x-coordinate from the point that we have. So we have these pieces of information that we use, and we plug it into this formula. Then what we do is solve for y and simplify to y equals mx plus b. So we would have all of this from our slope and our point, simplify the whole thing to get to y equals mx plus b. So what we'll do is work on a few examples to get practice for this. So I'm going to give some pieces of information, and what we're going to do is write the equation. So let's say we had a line that has a slope of 3, and it passes through a point. It passes through the ordered pair 2, -6. So we'll say we have a line that fits this description. The line has a slope of 3. It passes through this ordered pair. What we need to do is write the equation. And remember, we need two pieces of information to write an equation. We need a slope, and we need a point. So the two pieces of information that we have, the slope is 3, and the point is 2, -6. So we have our slope, we have our point, we're ready to use point-slope form. So the point-slope form that we just covered, y minus y1 equals m times x minus x1. We're going to use the information that we have, we're going to use the point-slope form, and we're going to come out of this with an equation. Now remember, from the notes, this y stays y. This minus sign stays there. Okay, so the y stays y, the minus sign stays there. The y1 comes from the y-coordinate of the point that we have. The y1 is -6. So we're going to put here our -6. We're being very careful with signs. We'll clean some stuff up later. The equal sign stays there. The slope comes from the slope that we were given. So instead of writing slope here, we have a slope of 3. The slope is 3. We'll put the 3 down here. Ooh, catch the meter stick. So our slope is 3. This x stays x, this minus sign stays there, and x1 comes from the x-coordinate of the point that we were given. The x-coordinate is 2, the x1 is the x-coordinate from the point that we have. So we input our x2, or x1, excuse me. So here we have our point-slope form. What we need to do now is clean it up, simplify everything we can and get y by itself. So we're going to clean this up. If we're going to clean up y minus a negative 6, a minus a negative, that phone is again what we're going to ignore. This minus a negative becomes plus a positive. Remember, two negatives looking at each other becomes plus. So we're going to clean up y minus 6. We're going to call that y plus 6. Now we use the distributive property here, 3 times x minus 2. So we can now distribute 3 times x, which is 3x, and then 3 times that minus 2. 3 times minus 2, which is minus 6. So we're continuing on simplifying what we have. We're going to come out of the other side with an equation on our hands. The only thing we have left to do is to get this y by itself. And to do that, we just need to undo plus 6. And so we simply minus 6 on both sides of the equal sign. Now I can't take 3x minus 6. I can't subtract it there. I have to subtract it here. So I will be left with y equals 3x, and then just work this out. Negative 6 minus 6, it's not 0, it's negative 12. So the equation of the line that we have is now in slope-intercept form. So this is now in slope-intercept form. This is our equation. So the equation of the line that has a slope of 3 passing through 2, negative 6, the equation of that line is y equals 3x minus 12. And we used point slope form to get us there. Alright, so let's do another example to see if we can get good at this. Let's say I had another line that passes through the ordered pair, negative 4, negative 3, and has a slope of 3 over 2. So here's the information that I'm given. We're going to write the equation of the line that fits this information. And so we're going to work backwards. What we need to write equations of lines, a slope and a point. A slope and a point. And we have that information. The slope is 3 over 2. The point is negative 4, negative 3. Now that we have a point and a slope, we can use point-slope form. Y minus y1 equals m times x minus x1. Where the y stays y, the minus sign stays there. The y1 comes from the ordered pair. The y coordinate is negative 3. The equal sign stays there. The slope comes from what we were given, which is 3 over 2. The x stays x, the minus stays there, and the x1 comes from the x coordinate of the ordered pair. So we have plugged in all of the information that we need. Now the rest is cleaning it up. Use the distributive property, clean up our mess. We have a minus a negative, which is plus a positive. And now we have the distributive property. But before I use the distributive property, I'm going to clean up the mess inside the parentheses. I have a minus negative inside the parentheses. I want to clean that up as well. And now I'll be ready to use the distributive property. So I want to clean up as much as I can before I start doing some confusing things. Y plus 3 remains the same. 3 over 2 times x is 3 over 2x, or 3 halves x. Now, 3 over 2 times 4 times a positive 4, 3 over 2 times positive 4, I'm going to multiply 3 times 4 to give me 12 and keep the over 2. So it's a positive 12 over 2. And now I'm going to clean that up because I can. So I have y plus 3 equals 3 over 2x plus 6, and I am almost done. So all I have to do now is solve for y. I have a y plus 3. I'm going to undo plus 3 with a minus 3, and make sure I do it on both sides. And so I will have y equals 3 over 2x plus 6 minus 3 is plus 3. And here we have an equation in slope-intercept form. And so I know I'm done when I am in slope-intercept form. To continue with a couple more examples on writing equations from given information about a line and thinking about what we need to write that equation. So to refresh the memory, we need two things to write an equation. We need a slope and we need a point. So the question I have is, what would happen if I didn't give you a slope, but rather gave you two ordered pairs? So if I gave you 2 points, would you be able to find the slope? So could we do that from 2 points? And that's what we'll investigate in the next couple of examples. So remembering how we can find the slope from 2 given points is going to be helpful. So just like I covered in previous knowledge, the slope formula is the change in y over the change in x. The change in y over the change in x. So once we have our slope, what we can do is use either point to continue moving forward with the point-slope formula. So this is where things get a little bit complicated. So here's an example. I need to write an equation, and what if I'm only given this bit of information? 2, negative 3 is a point that it passes through, and 5, 3 is another point that it passes through. Can we find the equation of the line that passes through those 2 points? So this is all we're given. We have to come up with an entire equation for that. And we can do that by remembering the slope formula. Slope is the change in y over the change in x. And remember, part of the previous knowledge I talked about labeling your points. x1, y1, and x2, y2. If we label our points, we can then use all of our information for our formula. So let's find slope. Slope would be y2, which is 3, and then the minus is from the formula, y1, which is negative 3, and we have to put that over the change in x. x2, which is 5, and then minus from the formula, x1, which is 2. So we're just plugging in the information that we have into the slope formula, and then we'll be able to find out our slope, and then we'll have our slope in a point. So now we just need to subtract appropriately. 3 minus negative 3 is the same thing as 3 plus 3. 5 minus 2 is at the bottom. So our slope would be 3 plus 3 at the top is 6. 5 minus 2 at the bottom is 3. And we can simplify this slope. 6 divided by 3, of course, is 2. So we have our slope. And remember, we need a slope and a point to write a formula, or to write the equation. So the slope we have is 2. The point we have is, well, we have a choice, and we can use either point. It does not matter which one of these ordered pairs we use for our point. Doesn't matter. We can use this one here, we can use this one here. It doesn't matter. I like to use numbers that kind of match up with the slope. If I have a 2 here, I'm going to use x1 and y1. Don't need to mess around with 5s and stuff. So the point that I'm going to use is 2, -3. And now I am ready to write my equation. I have my slope, I have my point, I also remember the point-slope formula. Y minus y1 equals m times x minus x1, and I am ready to put all of that information in so I can write the equation. Y stays the same, the minus comes from the formula. Y1 is the y coordinate, which is -3. The equal sign stays. The slope is 2. That's what we found using the slope formula. X stays the same, the minus stays the same, and x1 is 2. So we've plugged in all of our information from the slope and the point, and now we're ready to clean all of this up and simplify it to get an equation. So we have that y minus a negative. We don't want that. We want that a plus. And now we have the distributive property on the right-hand side. So we have 2 times x, and 2 times x is 2x. And we have 2 times -2, which gives us -4. So we've cleaned up, we've used the distributive property. Now we're almost done. We just have to get the y by itself. All we do here is subtract 3 from both sides. And we will have left y equals 2x, and all we have to deal with is -4 minus 3, which of course is -7. So here's our equation. Remember, we started with 2 points. The line that goes through these 2 points, we end with the equation of that line. And we're able to do that by thinking, making sure we remember that to write equations, we need a point, which we had to, and a slope. We weren't given the slope, we had to find it using the slope formula. So we're going to do another example that's very similar. So now what we're going to do is write the equation of the line that passes through 8, -2, and 2, 1. So there's a line that passes through these 2 points. We need to write the equation. In order to write the equation, we need a slope and a point. Here we have 2 points. We don't have a slope. So we have to find the slope. And the way we find the slope, again, is using the slope formula. The change in y over the change in x. So we're going to use the slope formula to find the slope. Now what we do is label our points, label them correctly. The x coordinate, the y coordinate in the first order pair, the x coordinate, the y coordinate in the second order pair, and now we just plug that into the slope formula. So slope is y2, the minus comes from the formula, y1 is -2, all of that is over, x2 is 2, the minus comes from the formula, and x1, which is 8. So we have our coordinates plugged into the slope formula. Now we just need to subtract correctly and see what we come out with. At the top we have 1 minus -2. That's 1 plus +2. At the bottom we have 2 minus 8. So So the slope would be, at the top, 1 plus 2 is 3. At the bottom, 2 minus 8 is negative 6. And we can simplify this. 3 over negative 6 is a negative slope, but we can simplify it. The top and the bottom can both be divided by 3. That leaves us with a slope of negative 1/2. So here we have found our slope, negative 1/2. But remember the goal. The goal was to write the equation. And in order to write the equation, we needed a slope and a point. We have our point. Now we have a slope. Now we're ready to write the equation. So we're going to set up our information. I have my slope is negative 1/2. I have a point, more than one actually, and I can choose either point. I can choose to work with this point, or I can work with this point. Since in the previous example I used the first point, x1, y1. For this example, I'm going to use the second point, x2, y2, and show that it doesn't matter which point I use. I'm going to use 2, 1 as my point. I have a slope, I have a point, my thinking is almost done. Now all I have to do is plug things into the point-slope form. Y minus y1 equals m times x minus x1. And you might be thinking, wow, that's a lot of formulas. But we're thinking, we're using our brain, we have to piece together what is the path that we have to take in order to become successful. And so we've used one formula to find slope. We're going to use this formula to write the equation. So we have y that stays y, the minus sign stays minus sign. y1 comes from the coordinate, which is 1. We have our equal sign. We have our slope, which is negative 1/2. We have the x that stays x, the minus sign from the formula, and then x1 is the x coordinate. From here, we just use the distributive property. We don't have anything to clean up. So on the left-hand side, y minus 1 stays the same. On the right-hand side, negative 1/2 times x is negative 1/2 x. And then we have negative 1/2 times a negative 2. Negative 1/2 times a negative 2. And I'll show you the long way. A negative times a negative is a positive. So a negative times negative is positive 2 over 2. And now we can clean this up. So we'll have y minus 1 equals negative 1/2 x. 2 divided by 2 is 1 plus 1. Finally, I just need to solve for y. Add 1 to both sides, and we are okay. So our equation is y equals negative 1/2 x plus 2. So again, we started from two ordered pairs. We needed a point and a slope. We had a point, we just needed a slope. We found the slope, used the point-slope formula, cleaned it up, wrote the equation. So now, very quickly, let me show you, what if I used the other point? What if instead of working with 2, 1, I used 8, negative 2? So I'll show you very quickly what that would look like. So I've had the slope of negative 1/2. What if I used the other point? What if I had used 8, negative 2? So I'm going to do this very quickly. I'm going to start with y minus y1 equals m times x minus x1. I'm going to use the distributive property. And then I'm going to solve for y. So I have y equals negative 1/2 x plus 2. using this point, what was the equation when I used the other point? Y equals negative 1/2 x plus 2. So it doesn't matter which point you use, you'll still have the same equation. That is it for this lesson on writing equations given a point and a slope, or given two ordered pairs. Next time we'll cover what we do with parallel lines, perpendicular lines, vertical lines, and horizontal lines. Good luck.